let me know if you have any issues with the connection, please. We're gonna continue talking about object-oriented programming, so classes. We've done the last time an exercise which is diffraction, to define, fractions using object-oriented programming in Python. Okay. So to start off, just a quick reminder of what object-oriented programming is. So it really allows you, it's a mechanism that allows you to create your own data types through classes. So data types that are not already supported by Python, and you want to create them to be able to use them in your programs, you can do that using object-oriented programming by defining a class or more than one class. When we talk about object-oriented programming, we write code from two different perspectives. Implementing a new object type. So I want to define a new object type like a fraction or a student or a point. Okay, that's really creating or defining what is this data type, new data type. Yeah? So implementing a new object type with a class. You have to define the following. You have to define what are the data attributes, what are the properties of that object. Any object that is going to be a point, what are their properties? What are these things that they are composed of? Okay. Now, we also have to define the methods that allows you to interact with these objects, how to use these objects. Okay. Now, the other perspective is the following. Once I've defined the class or defined this new data type, how do I use it in my programs? So in my code, so how do I create instances of this object type, and how do I do operations with them? Let's be concrete. Let's look at a particular example. The class is the type. Yeah. So when I say a class fraction, this means I'm creating this new type called fraction. Yeah. So this is really how I define this new type. An instance is one particular object. So when I say f equal fraction of 1 and 2, right, because the fraction has two data attributes, the numerator and the denominator, this is an instance. This is the type, this is an instance. Class is defined generically. So really I use self to refer to any instance while defining the class. So if you remember the methods that we've been writing the last time, some of them have self. Yeah. Some of them have self, and other, and so on. Yeah, this is what I use to refer to a particular instance of this class while defining the class. Okay. Now, data, right? Values vary between instances. So each fraction that I create would have its own data values, would have its own numerator and denominator, like f1, which is half, and f2, which is 3 over 4. Yeah. So these have different values because they are different objects. Okay, so the class, its job is to define what are the common properties or data attributes among all instances of that type. Yeah, that's its job. And how do I interact with them? What are the common methods between them? Like, subtract two fractions, add two fractions, and how does that work? That's the job of the class definition. Okay. The instances would all have the same structure of the class, meaning that every instance that I define, so f1 and f2, they would, have denominator and numerator. They would have, the addition method or support the addition method, support the subtraction method, and so on. Okay, just to differentiate between these two sides of class. Let's do one more exercise to kind of put this all in your head again. So we're going to create a new type to represent a set of integers. Right? What does that mean? Let's see, right? If I say s, I want to create something like this in Python. I want to be able to create something like, 1, 3, 7, right? So this is a set which contains 3 elements, and don't get confused. This is not a dictionary. Remember, dictionary has a key and a value. I'm using the braces, which is the same as, dictionaries, but this is, I don't mean here a dictionary. Right? It's a set which contains 3 elements, 1, 3, and 7. Mathematically, what are the properties of sets? You have unique elements, so there's no repetition in a set. It doesn't make sense to do 1, 1. Typically, you print them in order, so ascendingly. always print them, you know, I put the smallest value as a convention. I put the smallest value first, and you know, next one, and then the next one, and so on. I can add an element in a set, you know, and the set will check if, you know, this element exists. It doesn't do anything. If it doesn't exist, I add it, and I can remove an element from a set. Okay. So here is what I want to do. I want to create a class that represents, you know, sets. And the internal data representation, I'm going to use a list. Right? So I'm going to, you know, implement this using a list. Okay. So that my implementation is going to use a list, right? And the set is initially empty, right? So I assume that the set initially empty. So when I create a new set, it's always empty, and then I can add, so insert an element there. So the method that inserts an element, I give it an integer, and it inserts it if it's not there, and remove an integer. So it's gonna look in this set and see if this E is there. If not, right, return an error. Yes, sets exist. Right? What we're trying to do is show you an example, a demonstration. Yeah, we did something last time that also exists. Fraction, for instance, exists as well. Yeah? But we implemented. Yeah, we're not. The whole point is to kind of give you an exercise on how to do this. Okay. Yeah. So let's do this. I'm going to start the code with you. So let's copy this. And let's write the code together. I called it integer set. You can call it anything you want. Let's start writing this code together. Please be interactive as much as you can. So class, I'm going to call it int set, right? Just the way of calling it. What does this line of code do? It tells me there is a, you know, a class. I'm defining a new type called int set. Okay. Great. What is the first method in this class? If you remember anything from what we talked about Friday and on Monday. What is in every class, what is the first method you write? The init, right? So basically the constructor, exactly. So I start with diff. This tells me how, you know, I can create an object or an instance of this type. And what does it take? Self. We said we're going to implement the set using a list. So internally, the elements of the set, the integers, are going to be stored in a list. Okay, so this is really how I'm going to implement it. Okay, so how do I do this? So I'm going to, you know, L, right? It's going to be an empty. So self.l, right? So I'm going to assume there is an, you know, every object has internally a list that is storing the values in the set. And it's an empty list. That's all it does, right? It initializes an empty list, and that's all it does. Okay. What else do we want to do? So here's what we did. This is what we did, right? We said, you know, to represent a set internally, we're going to use a list to store the elements of the set. Okay. We need to make sure that every integer appears only once in the set. Yeah? So really don't store an element more than once. Okay, now I can insert elements inside this set. That's a second method I want to define. So diff, right, insert. What does it take as parameters? So I want to use this method to insert an integer into the set. So self, for sure, because I have to call it, like, you know, instance.insert. But if it's self only, right, I want to insert a particular integer. I want to say insert 5. Other, is it other jet? If other, it means that you're inserting another set. Yeah. So of course you can call it other, but what I'm asking the type, right? I'm assuming that you mean by other is also, you know, a set. So I want to insert some integer e. I'm calling it e. Okay, so basically this method is going to be called by the instance.insert, and it's going to pass an integer as a parameter, yeah, that I want to insert in the set. Okay, how do I insert actually in the set? So the set is nothing internally but a list, an empty list, yeah, or a list that contains some elements. How do I insert an element in a list? Yes, I do self.append self.l, right, to refer to the list.append of e. That's great so far, right? So all I did is just I took 5. I have a set s. I'm going to say set.insert 5, and it's going to put it inside the list. That's great, but this will allow repetitions, correct? So now if I try to insert 5 again, it's going to insert it as the second element in the list, or the fifth element in the list, and so on. So I want to make sure that I only insert an element inside this list, the internal representation of set, if it's not in self. Exactly, Misha or Michael, sorry. So I'm going to say an if statement. If e not in self.l, right? First check, is this guy in L or not? If it's not, append it to self.l. Otherwise, just ignore it, right? Basically, when you insert 5 in a set and it's already there, nothing happens. Excellent. Okay. How about removing an element? So I want to remove, create a function called remove. Again, takes self and e. So it takes a particular integer, and removes it from the set if it exists. How do I do that? So assume the set has now, like s, my s has 5 and 7. Okay. And then I want to remove 7. So I want to call s.remove r of 7. Sorry, I'm using r, right? But the annotation would take me forever. So s.r representing remove dot 7. I want to be able to remove 7. Delete, right? So I use the delete method from the list. Right? But what happens if the element is not in the list? So what Jad is saying is the following, right? Do self.l dot delete would not. I think it's is it delete? What is it called? Let me see. Remove. It's called remove. The method is called remove. Yeah. So dot remove of e. Okay, great. Yeah, that's what we want, Michel, right? We want to pass an element. Yeah, delete, exactly. Right? Delete takes an index, so I say remove the third element, but I want to delete or remove a particular element, a particular value from this. So that's why I'm using remove. That's excellent, but the only issue is the following, right? It's going to give me an error if 7 doesn't exist in the list, yeah, which is fine, but it's going to print an ugly message. Let's try it out, and then I'll explain to you what I mean by this. Okay. So here's why I've done these two methods, one to insert and one to delete. Let's try to use it. So I'm going to define a set s, which is basically integer set. When I write this line of code, what it's going to do is it's going to create an empty list internally, and you have now an empty set, representation of an empty set. Okay, now I can say s.insert 5, s.insert 7, okay, s.delete, sorry, .remove 5, and then s.remove 3. Okay, so I created a set, I inserted in 5, I inserted in 7, I try to remove 5, and then I try to remove 3. Let's run it and see what happens. Okay, I'm gonna do Python. Okay, so here's it give me an error, right, saying self.l.remove list.remove x. X is not in the list. This is fine, but maybe I can do this nicely, because now this revealed the following. This revealed that the internal implementation of SAT uses a list. Yeah. So maybe I can make this nicer. I want to say the following: if E in self.l, remove it, right? So if the element exists in the list, I remove it, else print E plus or string of E, right? Because it's an integer, not in the set. Okay. Just to make it more user friendly. Now let's try it again. Just data, check the element. Is it in the list? Remove it. If it's not, print, the element is not in there. Now, what it does, it says 3 not in the set. Okay. Questions so far? Okay. Let's print the S after all of these operations. Okay. So who can tell me what S would be if I print it now? I created an empty set. I inserted 5. I inserted 7. I removed 5. I removed 3. 7. Okay. So you expect it to print 7. All right. Let's see it. This is what it prints. Rawad was saying empty list. Some people were saying 7, right? This is what it reads. We need to define exactly, Mike. We need to define if you're going to use a print for this object and you haven't defined, this method, special method string, it's going to print the reference of the object, where in memory this object is. So it tells you, this is an int set object at this position in memory. Very uninformative. So I wanted to actually print the elements of the set in a friendly way. So I have to define the special function, as Michelle said, string. Okay, what does it take as an argument? The method string takes self, right? Because I call it, the object or the instance or print of the object. Yeah, so it takes self, and it has to return a string that is going to be printed on the screen when I call print. Type. I want to print the following. I want to be to print a set. I want to print it in that way. So like this. I use a brace and then list the elements in the list in ascending order. So here I inserted 5, and then I inserted 7, and then I removed 5. Right, so I wanted at the end to print, the list with just 5. So braces, then the elements inside the list, then then another brace at the end. Why we needed to define this? I just showed you, Jad. Without it, it's going to print the following. It's going to print this is an object of type int set at this position. To be able to print this, to be able to print, the elements of the list and the curly braces, I have to override the string method, to write something informative. If you don't define a string method, it's going to print just something like this. What is the type of the object, which class belongs to, and where it is in memory. Anything you want to print, that makes sense, you have to do it yourself by defining the string method. Clear? Okay, good. So join. So Rawad is saying print, and then he said, braces, and then comma, and then join of sorted of list plus. So I don't know what join this join mean, right? So you're calling a method called join that is not defined, right? But yes, we need to sort. We need to do something. So let's try to think about this logically together. How about the following? I want to write the elements in order. So first thing is I'm going to do, self, right? Dot sort. Right? So sort the elements inside, the list L. Okay, I know there's no repetitions, and now it's going to be sorted in ascending order. Now, the second thing is the following, right? To create a string, right, that I'm going to print, right, which is initially a brace, an open brace, right? And then loop over the elements in the list for E in self.L. Right? So this would loop over the elements in L in ascending order now because I've sorted them. As T plus equal to, E, right, or string of E, because E is an integer, plus comma. Okay. So now I'm accumulating, right, after the brace, the elements and then comma, the elements and then comma. And then at the end, once I finish this loop, I, set st to be, empty, close the brace and return this st. If it's a join, it's I've never seen the join method, right? So maybe it is, right? But I don't think. Try it out. Try it. Yeah. You have your computer. Just try this method out and let us know if it works. Yeah. I know that there is, a pen. There is extend. Join is, you have a list. You have a string and you do join, right? So I think what you mean is. L.join or something like this, and that joins all the elements inside the list into a string. But I don't think this particularly writing join and sorted of list will work. Yeah, try it out. Yeah, I said right. It has something to do with strings, right? So you join the elements inside the list into a string, but the syntax is not correct. Yeah, Nisreen is saying, right, the last element have a comma. Yes, it does, but let's print it out, and then we'll deal with this first, right? Let's just do it step by step, Nisreen. Okay. So all I did was, looped over sorted the elements, looped over them, and created a string to have, all the elements inside the list. Let's run it and see what happens. So I'm going to insert, additional elements just to make it more interesting. So I'm going to say insert 7 s.insert 3 s.insert 2 s.insert 1 and so on, right? And then I removed 5, I removed 3. Maybe let's remove the remove for now. So ideally, what should this method print now? When I say print as this line of code, what should it print? I have inserted 5, then 7, then 3, then 2, then 1. What does the set have? Anybody knows? This set, right, was empty. So it should print, yeah, sorted, exactly, right? So let's see if we run it, what happens. And now what it prints is 1, 2, 3, 5, 7, and then comma as Nisreen has predicted. So how do I solve this? Can anybody tell me? So I want to get rid of the last comma. The problem is here the last comma, right? Because I'm adding an element and then a comma, an element and then a comma. I want to get rid of the last comma. How do I do this? Any thoughts? For E in self.L, for instance, you could do something like that, right? Yes, exactly, right? So it is how you use join Rawat, right? So you write a string, right? You give it a string that is separated, and then you pass it, right? Something like this. There's zillions of solutions. The easiest one, right, is to do the following, for me at least, to say, take from the beginning all the way till the end, right? So take the string, remove the last, character, or the last letter, which is this comma, and then, add a brace. Okay? Let's try it out. And now It works like magic. There are other solutions, and you know, you can try them out. Okay, Rawad, if that's what you did and it works, that's fine. Yeah. Okay. Great. Let's test the whole method. You know, now everything. So let's say I print that, and then I do insert. You know, let's say 7 again. I remove 2. Then S dot remove, you know, 6, and then I print S. What will be printed in the second one? Let's see, you know, I inserted 7 again, I removed 2, and then I removed 6. What is going to be printed if I run the code now? The initial set had, just to help you, had the following: 1, 2, 3, 5, and 7. Right? And then I'm going to insert 7 again, remove 2, remove 6. Can anybody tell me what it's going to print? Let's try it out. Exactly, 1, 3, 5, 7, as Muhammad is saying. So it started with 1, 2, 3, 5, 7. It says 6 is not in the set, and then it prints 1, 3, 5, 7. Exactly, right? And that's it. I hope now, you know, sets are much more clearer to you, or not sets, I'm sorry, like classes, because we're going to build a lot on this. Yeah? So these are the foundations. We haven't talked really about something new yet. Okay. Let's do another exercise. For example, first of all, do you have any questions about the previous class? Okay, so we're going to do another exercise today, and that's it. So let's say the following. I want to represent animals using Python. What does that mean? I want to create a type called animal, or a class called animal, which represents different types of animals. So here we have, you know, cats, rabbits, and so on. And we're going to build on this class a lot on Friday as well. So looking at this slide, yeah, can somebody tell me what are the data attributes of an animal based on this slide? What are the, you know, the things, the variables, right? The class variables that I have to define inside this class. What do you see common between these? Self.name, Khaled is saying, okay, so a name of an animal, and self.age. Exactly. Perfect, right? This is the perfect answer. So we looked at this slide, so that for every animal, I have two really properties, a name and an age. Yeah? That's what all I need to define this class. Okay, so basically an animal is nothing but a name and an age. Yeah? Okay, so two data attributes, age and name. And I want to initiate the object by setting age to 0 and name to none. Okay? So let's write this together. So I'm going to do animal. Okay, I'll open this guy. Okay, I'm going to define a class called animal, which again inherits from object. Okay, and then the first method is init, the init constructor, right? And it takes self and name and age. Right? So what does it say here? Yeah. So initiate the object by setting age to 0 and name to none. So it should not take a name and an age. Yeah, because when I create an animal, it's a baby, right? It just was born. There's no name and the age is 0. So I really don't need to pass an age or a name. So I'm going to do the following, right? I'm going to say, you know, self.name is equal to none. and self.age is equal to 0. So every time I create a new object or an instance of animal, immediately the age is going to be 0 and the name is going to be none. Okay. Here's how it is. So I define initiate. It doesn't take any parameters because I already set these guys. I know they have some values, particular values that I want to set them to. Like what we did in the previous exercise. I set the self.l equal to an empty list. I didn't pass a list. Okay. Now, how do I create an instance, an object of type animal? All I have to do is just call, the constructor. So I say the name of the class, right, and empty parentheses because it doesn't take any parameters. Okay. Now, a.age is going to be equal to 0, and a.name is going to be equal to none. Right? So, other words, if I now have the class definition like this, I can say a is equal to animal, empty parentheses. And now I can say print a dot age and print a. Why is it complaining? Let's run it. I'm going to say 0 and none. Right? If I create another object B, which is an animal, or C, each one is going to have, the age is 0 and the name is none. Okay. Why I'm doing this exercise? Because I want to tell you something very important when you're writing object-oriented programming. We need to do something called information hiding. What does that mean? So I might change the name of the data attribute. Let's say I'm defining the class, and you're using it in your code. So you went here and opened Python shell, right? And you said from animal import animal. Yeah. So I'm the one who's writing animal, and you're using it. You don't know what's outside the class or something like this. Yeah. Okay. So it printed 0 and none because I have this in the definition. Yeah? So I'm going to remove this. I'm going to just do an import again. Okay. Now I can use it inside my code. You can use inside your code. You can define an animal like this. Right? And you can say a.age is going to print 0. A.name is going to print nothing, right? Because it's empty. It's none. Okay. Now let's say I have the code and I change this to years instead of age. Yeah? You don't know, right? You're just using my code without really looking into it because, like you import libraries, like the same way you import libraries. Okay. And now I do again import animal, and I say a is equal to animal. Then I say a.age, right? It's going to give me 0. I have to, I guess, did I save? Okay. Let me see. Let me control C. Then Python, then from animal import. Okay. Now I say create an object of type animal, a.age. It gives me an error, right? This object A or this class animal doesn't have an attribute called age anymore. So what is the whole point of information hiding is to allow, an independence between the data attributes inside the class that is defined and the usage. Okay. So for instance, in this example, I replaced age by years. You don't know that. You're just using this class in your code, and I might have changed the name of the attribute. Yeah, so you will get some. Okay. So that's what we're saying. So Python in general is not great at information hiding, but you need to do that yourself. In other words, right? So Python allows you to access data from outside the class definition. We've just done that. We said, a.age or a.name, like here, and a name, none. Yeah. So I'm allowed to, access data attributes from outside the class. Yeah. It It allows you to set them. So I can, take this A dot name, right, and set it to, let's say, cadeau, right? And now if I print the A dot name, it's going to be cadeau. So I'm allowed to set, the data attributes or the properties of an object from outside the class definition. Yeah. It even allows you to create new properties for a class. So I can come here and say A dot, I don't have it in the definition except name and age. I'm going to say, size. And I'm going to set it to time. And it's not going to complain. It now knows that this object A has 3 properties, years, name, and size. If I print A dot size, it's going to say time. And this is horrible, right? This is really very bad. Okay. Forget about this long introduction. Please focus on the following. Every time you write a class, you define your new type. Whatever properties you have defined or data attributes you have defined, like here age and name, you have to do what is called getter and setter methods for them. As a good style, as a good programming style. Yeah? Like similar to writing commands, this is really highly recommended. What do I mean by this? You write, so I have here 2 properties, age and name. Yeah? These are the 2 data attributes that I have for an object of type. I'm going to define 2 functions. One is called age, get age, and one is called get name. These are getters. The job is to get me the value of the attribute. So all it does is return self.age, return self.name. Yeah? So I'm returning the values of the attribute for every instance using these getter methods. Why? This abstracts, things or hide information. So if I change here, then this name, all I have to go and change, this method. From outside, it's exactly the same. The usage is exactly the same. Yeah. Also setters. I have to define setters. Yeah. So basically, if I want to set the value, don't immediately set it from outside by saying, a.age is equal to 23. Use the method setAge. Yeah. So basically, you say, okay, there's a method called setAge. Its job is to just set the age of an animal. Same thing for the name. Yeah. So don't really use or access data attributes directly from outside, by doing instance of the data attribute, rather than doing this, define setters and getters to access or set these values. Yeah. So these are the ones used outside the class to access data attributes. Okay. So when I do the following, A is equal to animal, and then I say print A.age, that's bad. Why? Why is this bad? Or A.name, why is this bad? Because I'm accessing the data attribute directly from outside the class definition. Instead, you should say print A.getAge, yeah? Where this is a getter method. All it does is return A.age. And the same thing for name here. When I want to set age to 5, that's bad. Or I want to set the name to cadeau, that's also bad. Instead, use the setter method. So A.setAge to 5. What is the job of setAge? It's a function inside my class definition that just sets the age to 5, and the other one sets the name to a particular value that I pass. Okay? Let's try this out, the code for this. So this I'm going to define setters. Here I have 2 variables, name and year, right? So I'm going to define get name, right? It's a method that takes self. And what does it return? It returns self.name. That's all it does. Right? Also, I call it with the object dot, get name. Doesn't take any parameters, and it just gives me back the name of the animal. And I'm gonna define get age. It's a method, also takes 1 parameter self, and it returns self.age. Okay, that's all it does. And I'm gonna define a setter for the name and a setter for the age. So that name takes 2 parameters, the object and the name. Yeah. So what it does, it says self.name. Okay. And I'm gonna define setAge, which does the file, right? New age, and set self.age equal to. That's all I'm trying to tell you right now. Yeah, for every data attribute, it's always a good practice to create these two methods: a setter and a getter. The getter job is to retrieve the value, and the setter job is to set the value, rather than just using the attributes. If you to be able to set these values or get these values from outside the class definition. Yeah. Let's try to use it. So I'm going to create an A. It's an object of type animal. Okay. Again, this would set the name to none and the years to 0. Now I want to set the name of this guy to Cadeau. What do I do? So I want to call A, right? A has the name Cadeau, right? Its name is Cadeau. How do I do that? The right way to do this is to what? Should I say A.name is equal to Cadeau? Is this okay? It will work, but is this okay? Is this a good practice? Any thoughts? I use the set, right? So basically, I call instead of A.name is equal to Cadeau, what do I do, Agma? A.set name equal to Cadeau. Right? This is good practice. How do I set the age? To 5. A.set age. That's all I have to do. Let's say I want to print A.age and A.name together. Is this okay? Yes, I can use it, but let's say I want to just print. I don't need to write it in a string. Of course, yes, you could write A, print A if I want to print A. But if I just want to print name, comma, age, I use the getter exactly, right? So I use A.getName. Don't use the variable directly. Use A.getName. Right, this method and string of A.get. Just a good practice. Okay, let's run it. I'm just gonna say, Cadeau and 5. So A knows that the names is Cadeau, and A's age is 5. All right. Yeah. So just remember this. It's a side thing, but please take this into consideration when writing classes. Yeah. It's for, if you have 3 variables, you're going to use 6 methods. One is setter and one is getter. Always, right? Not only in Python, in any programming language. What do you mean by not exposed, Agma? You mean private? You can do some similar to Java. So I assume you're talking about something like Java or C++, right? You can do something like this in Python to an extent, but the whole point of these getters and setters is that they're not private, right? You want people to use them. You're the one who sets whether something is private or exposed or not. Typically, you're going to make the getters and setters public, right? The other ones, the variables themselves are going to be private. Yeah, that's the point, really. Okay. Last thing I'm going to do, let's define a string, so that I can print A. So how do I do this? I'm going to do this. What does it take? Self. We'll talk about inheritance on Friday. Yeah, let's not complicate things too much right now. Okay, last thing I want you to do. How do I define the string method? So I can print here A. If I print A, it's going to print, that this is an object of type animal, and yeah, okay. Sorry, let me remove this. So if I print A right now, it's going to just print that this is an animal object, at this position. Okay. How do I make it print, something meaningful? I have to define the string method. Right? So for instance, what can I do? I can say print, return. I want it to return a string. Return animal, something like this, right? Plus str or plus name plus is plus, string of self.h. What does it do? It's going to say animal Cadeau is 5 years old, or years. Let's see what it prints now. Okay. Animal Cadeau is 5 years old. Okay. All right, I'm done here for today. We're going to talk about inheritance on Friday. Please review this lecture. It's very important for you to understand classes because inheritance is going to build heavily on that. So please look at the video if you missed a few things here and there, and start working on the assignment if you have, so that you're able to follow on Friday. Questions? Yeah, sure, Jet.
بروفيسور بس في اعمل لك شير سكرين.
Me, would you use that? Yeah, we can do that, right? But let's wait to make sure that nobody else has questions before we
Okay, بالاخر.
Okay. Anybody has any questions? Okay, good. Then I'll talk to you on Friday.